Okay, hi everybody. My name is Mark Allard with DataLogic, and I'm here to show you our latest and greatest vision solutions focused on a couple of products that were launched in the last year or so. Our Smart VS vision sensor and our P2X series of smart cameras. So I've set up a couple of simple demos here just to kind of show you some of the features and capabilities of these great devices. So starting with the Smart VS. So this is our latest entry into vision sensors, and it uses machine learning by the process of teaching a series of good and bad images. The device is able to learn the algorithm, and you're off to the races just with a button press of the device. We also have a browser-based web application you can use for training, but it can't beat button pressing on the machine for simple teaching. So I've got a couple of easy demos here. One is just using the simple juice bottle, and we're just going to check for presence of a cap, so see if the cap is present or not. And I'll take you through teaching of the sensor, which is really, really simple. So a couple of red LED indicator lights on the bottle here show that I'm within the field of view of the sensor. I've got a button right on top of the sensor here to activate the teaching mode. So it's just a series of button presses to teach the sensor. So initially it's one long press to put it into teaching mode. I'm blinking green. This is where I'm teaching good images, and I can teach up to a total of 6 images between good and bad. So this is a simple application, cap present or not present. So I'm just going to teach one good, one bad image. So single press to teach my good image with the cap in place. Now another long press to switch over to teaching the bad images. Now I'm blinking red to indicate that I'm teaching bad images now. Another short press to teach my bad image. Let me take off the cap first. Okay, now that I've taught my good and my bad image, it's another long press to put it into active mode. And when it's done blinking and glowing steady green, that means I'm in run mode now. So I can simulate a trigger sensor just with pushing this button here. And as I push the button, it's a little bit probably difficult to see on the camera, but it's flashing red to indicate that that's a bad image. Okay, I can move it around a little bit within my field of view, and I still get a bad indication. If I put the cap back on, and we trigger it again, we're flashing green now to indicate good inspection. And like I was saying, we do have a web application. You just type the IP address into your web browser to connect to the sensor, and you can teach it through the browser application, which is advantageous because you can actually see the image that's coming from the sensor. So depending on the complexity of the application, it might be better to bring up the web application as opposed to teaching with the button presses. Now I'm going to pivot over to our P2X series of smart cameras. So these are full-featured vision devices capable of handling up to moderately complex vision inspections. So just pointing out a couple of features of this particular camera. One, along with all DataLogic cameras and barcode readers on the industrial side, we have a rotating connector block that eases installation. A lot of other manufacturers, it's a different model number, and sometimes you don't know until you're going to install it that you actually need the right angle versus the straight exit. A couple other features. This frame around the outside is actually filled with LEDs, and you can program it, and you'll get to see that in a moment, to glow green to indicate a passed inspection, glow red to indicate a failed inspection, or yellow or blue to indicate a warning to an operator. So it's a nice visual indication to somebody in the vicinity that your inspection is working as it should. A couple of different LED options that we offer. I've got mounted here the 14 LED illuminator, and on this guy here, the 36 LED. So a lot more flexibility in terms of area coverage, working distance coverage with the 2 LED options, and we have a series of different wavelengths of lights as well. I did want to also point out that the camera has an onboard accelerometer, and the advantage there is that the camera is able to detect when it's been bumped or if it slips. So if you've got a loose screw, a loose bracket, and the camera slips, is no longer looking at your conveyor, for example, it might be tough to come to that. It might take some troubleshooting and some wasted time, downtime for your production line, right? So instead, you can program your bezel to light up. You can send a message to your PLC and indicate the operator that you've lost your orientation, that the camera needs to be readjusted. Okay, now I'd like to jump into our Impact software suite that's used to configure not only our P2 smart cameras, but also our Windows-based vision processors. So that's a big advantage of the DataLogic Vision line, is it's one software suite to learn for both our smart cameras and our vision processors. So it covers a number of different applications from medium to high complexity. So jumping into the software here, we're looking at Vision Program Manager. So Impact is made up of two applications, Vision Program Manager, or VPM, which is used to configure your cameras and design your vision program. And the other application is Control Panel Manager, or CPM. CPM is used to design custom HMI screens to interface with your vision system. So you can display live images, you can display known good images, you can password protect the screen so that only certain operators are allowed access to the screen. You can make changes to your program. You can select the program depending on the product that's being run at the time. So it's incredibly flexible for every kind of application. So taking a closer look at the software here, again, we're looking at VPM. And just to kind of give you a flavor of the software, what we're looking at. So in the upper left-hand corner here, we're looking at our project tree, which is showing the devices that I currently have connected and the programs that are currently loaded into the device. In the bottom left here, we have a number of drawers, tool drawers, as we call them, that contain our inspection tools grouped by categories. We have over 100 inspection tools. It's a drag and drop interface. So if I wanted to, for example, add a blob tool, I can just click on my blob tool, drag it over into my program, and then it's configured over here in the lower right. I'll go ahead and get rid of that. In the middle here is my program tree. So like I said, it's a drag and drop interface to add new tools. It executes from the top down, so it's highly intuitive once you add new tools. Over here, obviously, is the image that I'm working with, that I'm using to build my program. And then, as I said in the lower right, that's my configuration pane, right? So it's a setup-based configuration for each of my tools. Again, highly intuitive once you spend a little bit of time with the software. So you can see I've got a number of tools already loaded. I'm looking at a laser-etched metal card here that allows me to demonstrate several tools. So specifically, I'm reading the QR code on my card here, and I'm also using the center of that QR code as the origin for the rest of my tools. So if I move the card around within the field of view, all of my tools pivot along with it. I'm also doing a pattern find. So if I jump into the pattern find tool, just as a simple example, you can see down here, I've trained this 8 LED text as a pattern. So I'm not reading those characters. I'm essentially looking at that cluster of bright pixels, and I'm looking for that particular arrangement of bright pixels within my image as a pattern detection. I'm also performing an OCR. So OCR standing for optical character recognition, or essentially reading text. So in that case, I am looking at this P10 text in the upper right-hand corner. So in that case, OCR, I actually am reading, so I'm able to detect what characters those are printed on the card, and I'm able to verify that those are the characters that I'm expecting. I'm also doing a circle measurement, so this circle over here, I'm checking the radius of that circle to make sure that it falls within my expected range of values. And then, of course, I have a pass-fail tool that indicates whether my program has passed or failed. And then a visual feedback tool, which allows me to activate the LED bezel around the outside of the camera. And just a quick demonstration of that, if I trigger my camera here, you can see that my bezel lights up in green to give an operator in the vicinity just a quick indication that the inspection is passing. So by the same token, if I stick my hand under the camera and trigger it, you can see it turns red to indicate that my inspection has failed. So I'm now going to jump into the display mode of the program, of VPM. And I'd like to just briefly highlight that because the display mode is very useful when you're designing your program, when you're validating it for use on the line, and troubleshooting, right? So it's easy to see which tools have failed, and you can immediately jump back over into your program and make changes if needed. So what we're looking at here is, again, on the left here, we're looking at our program tree. And on the right here, I can see my image. There's a green border around my image and green indicators on the image itself that indicate that my program overall has passed and that each of these individual tools has passed. So I can trigger it, and I'm just kind of simulating trigger sensors here by clicking on this button here. I'm moving it around, I'm rotating it, I'm still passing. I think that red there, I went outside of the field of view a little bit. If I flip the card over, I've got some different printing here, and if I trigger it, you can see that I fail. So my border here turns red to indicate that my inspection as a whole has failed. And then I've also got some red indicators on the image itself to indicate the tools themselves that have failed. So now let's say I'm designing my vision program and I'm not sure what exactly has failed. What I can do is go over here, and I've got these red indicator lights that are positioned next to specific tools to indicate that that tool failed. So if I look at this light here, I can see that it's positioned next to my advanced OCR tool. I can click on this icon next to the OCR tool. And what that does is it brings me back into design mode and actually into that OCR tool, where I can take a closer look and see that the text that has been read, which is P15, as you can see, doesn't match the string that I'm expecting, which is P10. So the tool's failed. And because that tool failed, I've set up my entire inspection to fail based on that. Okay, and then from there, I'd just like to give a quick demonstration of the onboard accelerator on the camera. As I mentioned before, the accelerator on the camera allows the camera to be able to detect when it's been bumped or if the orientation has been lost, if it's slipped and it's no longer looking at the conveyor. So my camera's online right now, no indication that anything's wrong. So if I just go ahead and loosen my mount here and I tilt it, you can see that it starts to blink yellow, which is just one example of how you can configure the camera to react if it loses its orientation. So we've got it set up to blink yellow. There's actually a sample program available that you can get from DataLogic that you can load onto your camera just as a starting point. You can configure, you can change the color of the bezel to blink red, for example, if you want. You can change the duration of the blinking. And now if I move it back into position, it stops, and all's well again. So that's a little introduction to DataLogic Machine Vision. I hope you've enjoyed taking a look at our P2X series of smart cameras and our Smart VS vision sensors. And I hope you enjoy the rest of the expo here at HTE.